Hey, g'day, it's Prezzo here, back in the workshop, and as you can see, the Bridgeport is all back together. I'll give you a close look at it and then we'll talk about some upcoming projects. Now, I have trammed in the vise, and I've also trammed the quill housing and the head on the machine. All the electrical's gone back together and everything works, which is a good thing. And I must say, it was a fun project working on this. Were a few frustrating times, but all in all, I'm really happy with the way it's turned out. And the challenge now, of course, is to keep it looking this good, or at least as well as it can be, given that it's going to be a working machine. I mean, it's not a museum piece. So we're going to have to accept that it's going to get a few chips and marks and scratches, but that's the nature of working with one of these vintage machines and making sure that it's running nicely. Now, there are a few little jobs still to be done. This handle needs to be chemically blackened, and I'll probably do that with the parkerizing process so it looks the same as these bolt heads. Another job that needed to be done was to replace the original shelf that was inside this column. Oh. Did you forget to paint that? You idiot. So another job that needed to be done was to make a new shelf to go inside the column here, and here it is. And this is made of carbon fibre. I had a sheet that was just the right size and it cuts really easily with an angle grinder with a cutting disc on it. It was a real mission to get it in there, but that is going to be durable, it'll last forever. It's way strong enough, probably better than aluminium or steel. And it looks great, so there you go. That bloody horizontal head, what am I going to do? Anyway, let's fire it up and see what it sounds like. The power feed works. And also found out that the coolant pump wasn't broken. It actually does work, but it only works when the spindle is engaged. So let's see, there we go. And you can hear the contactor clicking in. So I haven't actually put any coolant in the tank yet, but I'm confident that's all working. Okay, what about the motor, you say? And full feed all works. Now, I may replace the spindle bearings at some point, but for the moment it's working and I'm going to leave it like that. I'm quite happy with it. Anyway, let's talk about the projects that are coming up for this machine. We're going to look at a series of upgrades. Now, these upgrades are in no particular order, but this is one of the jobs that I still need to do. These are the original scales off the head of the machine, and they're all pretty badly damaged and beaten up, and I want to be able to replace those. Next one involves making a pneumatic drawbar for this machine, so I went ahead and purchased one of these little butterfly impact wrenches. This is the correct size socket for the drawbar. That's going to sit up there, and we're going to make that out of a series of castings. In fact, 2 castings. I've got some linear guide bearings and some linear shafting for making that, so that's coming up. Another job that needs to be done is to replace the work light on this machine. Now, this is all that's left of the original work light. There was a cast iron bracket and some joints here, and instead I'm going to fit this little beauty. Now, this is a vintage low voltage work light. It's been stripped down, powder coated and reassembled, and I've retrofitted this with a LED spotlight. Now, this is 240 volt, and I know they're meant to be low voltage, but I don't know, I'm willing to take the risk. I did need to make 2 new covers for the joints here, and these are really nicely made. It's got an integrated switch on the back here, so I can connect this straight up to the 240 volts with an isolator. And my workshop has an earth leakage circuit breaker built in, so for anybody who's worried, if this did go faulty, it would trip the earth leakage circuit breaker, so that's an added measure of safety. Now the only problem is that this was originally fitted to a transformer housing and I can't use that because it's very, very bulky. So what I'll do instead is I'll cast a new bracket. So this will be cast in aluminium and that'll fit like that, and that can screw to the side of the RAM on the machine. So stay tuned for that little project. Now the real subject of today's video is this little gadget here. Now this is an iGaging EZview DRO Plus, and it has a magnetic scale which attaches to the quill housing of the Bridgeport, and it's got this remote LCD which can be attached somewhere else. Now we'll eventually get a conventional 2-axis DRO to go on the X and Y travel for the Bridgeport, but in the meantime this is going to keep track of the Z travel, at least from the quill down. The knee travel I'm just going to have to rely on the micrometer collar for that. Now there are a number of commercially made kits that you can buy for this type of scale, and they consist of either 3D printed brackets or some sort of a CNC machine bracket, and they usually mount to the original 2 holes where the Z-axis scale would go. The only problem with that is that it means you need to remove that scale, and it removes that functionality. So if the batteries ever die in this thing, and it is battery operated, it means that you would have no way of actually setting the depth of cut accurately or reasonably accurately. So what I want to be able to do with this is to mount it off to the side. So let's just have a look at where this might go on the machine. Before I started on the process of designing the bracketry for this thing, I measured all the important parts of the quill housing. So they include these 2 reference surfaces here, the quill stop screw and the quill stop knob. And I modeled all of that in my 3D modeling package. And then I found out that some enterprising soul had digitally modeled this Z-axis scale. And it's on one of the 3D sharing sites, and I'll put a link in the description below if you want to download your own copy of this digital model. But once I had these important surfaces here and the scale, I was able to design a bracket which looks like that. And the scale would mount off to this side on the right hand side. Now the advantage of having it on the right hand side is that all of the original paraphernalia that you see here can be left intact. So the micrometer nuts and the original Z-axis scale can stay there. I can still get to the quill lock and these 2 bolts here, so I can tilt the head if I need to. Now the downside of course is that you lose these surfaces. Now I'm not sure, but I believe that these edges are used to align the vertical axis of the head. I already have a spindle square which goes in the spindle, so I don't really need these anymore. So I don't have a problem with drilling any holes in here either. They're going to be M4 holes, top and bottom. And this bracket that you can see here at the moment is just rapid prototype. Now I made this on my laser cutter, and it's going to allow me to transfer or spot through these pair of holes, top and bottom, and eventually this piece of the bracket will be missing. So I'll only have this top Z section here and this bottom section here, and they're going to be made from 6mm thick aluminium, and like I say, this piece will be missing altogether. The other good thing about rapid prototyping is that you can make up a mock-up, try it in place there, and if it needs adjusting, you can do that very easily. Now I originally found that this section of the bracket was too narrow. The spacing between these edges wasn't quite right, so I fixed all of that up and cut a second one. So let's go ahead now, we'll use this as a drill jig, and we'll get the holes through and we'll get these tapped in for and get it all fitted up as 2 separate brackets. So there's our first hole, that's 2mm diameter, and I'm going to drill this out tapping size for M4, and we'll get that bracket temporarily attached, and then we can spot through the other 3 holes. So I've just drilled that top hole out to 4mm, and we can just temporarily fit this. And of course now what we need to do is make sure this is truly vertical, and we can spot the other pair of holes through, and this one here. I'm sure you're looking at this and saying, gee, that's not very accurate. You should be using at least an indicator or a master square or something like that. But when we eventually fit the aluminium bracket, there'll be a little bit of wriggle room to get everything aligned. So I'm not anticipating any real problems with this. And given that this acrylic is quite flexible anyway, I could spend all day getting this dead square, and it's going to move almost as soon as I put the drill bit through. It's just an awkward thing, unfortunately, to try and clamp in place with any sort of accuracy. See that? Wish I had a demagnetizing tool. Oh, I have got one. There you go, we're back. Demagnetized. You need one of those tools. Yeah, that's moved a fraction. It's probably about like 1/2 millimeter at the top, but like I say, I'm not too bothered. I'll probably drill this top pair of holes slightly oversized so I can do a bit of tapping and moving and so on and get these two separate brackets. Remember, they will be separate brackets, so I can get them aligned. So for the moment, that's how we're looking there. And these brackets also have slots, so even if I get this wrong, I can still move this left and right, top and bottom, to get everything aligned correctly. Anyway, let's go ahead, we'll get the rest of the tapped holes done, and I'll bring you back when that's finished. So I've got all 4 of those M4 holes tapped now, and what I'm doing is putting in place the replicas of what will eventually be the aluminium brackets. And you can see, I hope you can see that even with you know, tightly fitting drilled holes and screws and so on, there's still a bit of movement in that. So when I finally get all of this set up, there's going to be a bit of messing around to get everything aligned correctly. So there's our top one. Bottom one's much more straightforward. Okay, so our scale is going to go on there. So what I'll do now is get some holes drilled through so we can put our slotted Z-shaped brackets onto that and get that in place. But once again, this is a good thing about rapid prototyping. You can sort of make changes on the fly, and when you're happy, then you commit to making it out of metal. Well, there's everything fitted up temporarily now, and you can see that I can get some adjustment top and bottom because of the slots in these little Z brackets. And what we need to do next is connect the hole in the quill stop knob to the back of the reed head, and that's what that little bracket there is for. So there are 3 existing holes in the back of the reed head, and when that's screwed in place, this hole should line up exactly with the hole in the quill stop knob. And of course, as you track the quill up and down, the reed head should go with that. So what we'll need to do is to make a plug that goes into this hole, and that plug will need to be screwed in place, so it's sort of a rigid fit, but it should be capable of being taken out if necessary. And then we can get everything aligned there, and then we can do our alignment checks to make sure that the rail on the reader is aligned with the movement of the quill. So that aluminium piece I just made fits into the quill stop knob, and it's a sort of a sliding fit. It's not a precision fit, and I want to be sure that there's absolutely no play in that at all. And when this plate comes up, it aligns with the hole in the front, and I've decided to put an 8mm spigot on that with a 6mm thread inside that, so I can clamp this acrylic plate to the end of that spigot there. And just want to make sure everything's really rigid, and just to make sure this doesn't move vertically, which is going to be bad for the reading, we're going to drill a hole through here at 30 degrees, and that will allow me to put a grub screw in there and jack that piece really tight against the inside of the hole in the quill stop knob. So I'll get that all laid out now and get the hole drilled. So what I need to be sure of is that this is sort of pulled out to its correct distance, and we'll just mark that with some Sharpie. I'm just going to scribe a position on that. So we're going to drill a hole in front of that mark. As long as we come in front, we'll be good. So I've got a 30-degree angle block in the vise. I've got a spring pushing that angle block back against the fixed jaw, and I'll just put a 6mm socket head screw in that part there so I can hang on to it. And if I get that just resting on that angle block, we can clamp that. Now I'll need to take that angle block out when I drill through, just so I don't hit the block with the drill bit. So I got that set up there now, and I've found the center with the center finder, and I've got a 6mm end mill set up directly over the center of that piece of material. And we're just going to bring the table up, bring the knee up, and establish a flat surface before we center drill and go right through. Alright, that's pretty right, so it's going to drill through now. I've got to remember to get this angle block out of the way. Should be able to finish that off by hand now. I've got that M5 drop screw in there now, and it just protrudes through the other side there. And what we should be able to do is slide that in, get it the right way around. Alright, bring that acrylic plate up and slide that aluminium plug to the back of it, and then we should be able to lock everything in place. And that's now rock solid. It's not going to go anywhere. That should come up there, and if everything's right, we should be able to slide the reed head down. Obviously it won't come back up again, but once we get this hole drilled out, correct clearance size for M6, and get all that locked in, we should be good to go. And we can actually test this. Now remember, these acrylic brackets here are just temporary, but in reality they could probably stay like that, you know, unless you smacked it with a hammer or something. It's not going to break. But I am going to make them properly. They are going to be made from anodized aluminium. Anyway, let's get all this rigged up and we'll just run a test. Okay, I've got everything sort of ready to assemble now, and I've got this working, so I'll put it back together again and show you what it looks like. So our little aluminium plug just goes in there, just loose at this stage, and then we can screw our two acrylic brackets on, top and bottom. Okay, so that's all snugged up there now, and we can just bring that little aluminium plug forward, and this is loose at the bottom. And I've drilled this hole out here to 8mm diameter, and that'll fit over that spigot. And we've got an M6 screw to hold all that together. Alrighty, now we can tighten up our grub screw. I'm just going to hold that grub screw vertical while I finish snugging up this M6 screw here. Okay, and then we can tighten the grub screw. Alright, so at this point the bottom is loose. I can loosen the top as well. In fact, I might do that. I've got a hex nut on the inside. Alright, so that's loose. Now remember, we got some movement, top and bottom. And the idea now would be to very carefully drive that reed head up to the top. And then just snug that up. Don't over tighten it, just make sure it's sort of not going to move by itself. Alright, so that's sort of firm, and now we can drive the reed head all the way down at the bottom, and it should align itself. And we'll do the same down there, just snug that up. Alright, that's snugged up there. I'm going to tighten that bottom one fully now. Okay, so that's all good. So I just want you to appreciate how close I got this, and when I first started to do the assembly I was really worried that I was going to hit that socket head screw with this bracket here, but it just clears when it goes right to the top of its travel. Let's have a look at the bottom. So as we bring this down to the bottom of its travel, once again you can see that I've just got enough clearance at the bottom here. So I don't think I can make this any more compact than it really is, and the length of the scale that I got is just right. So let's look at how we're going to mount the display on the machine. Now, the display unit for this gadget came with a magnet on the back, a fairly strong magnet, and it also came with a screw and 2 nylon washers. And with the magnet you can sort of stick it to the cast iron head of the machine there, but there's no real flat surface. It could possibly go over there, but once again it sort of doesn't really fit or stick all that well. So I figured that the best thing to do is make some sort of a bracket and use the screw fitting. Now I've made an aluminium cranked arm here. It's 20 millimeters wide, 3 mil thick, and there's a stud and an existing nylock nut as part of the Bridgeport head. And just adding the extra 3 millimeters doesn't affect the locking of the nylock. So that made a convenient place to put the display. So if we assemble this, let's see, put one washer on top, one underneath, and we can screw the whole display in that spot. And for me anyway, that's exactly at eye height, and it doesn't get in the way. I can still get the oil cap open there. I can still use all my other controls, and it doesn't get in the way of the quill handle. And if you just snug that screw up there, that's quite firm. And for me, the most important thing is I should be able to zero it or start it without having to hold it and stop it pivoting. So that all works. It's, you know, it's not super rigid, but that's probably okay. There's a USB port on the side here, and we connect up the read head with the USB port, and then we can zero. And if I bring that, it's at the top of its travel now. It doesn't always return to zero, but it's not a big deal. You can just zero it before you start. And the other interesting thing is that you've got millimeters, you've got decimal inches, and if you're really hardcore, you can use fractional inches. Not that I'll ever do that, but anyway, it's there if you need it. So let's go back to proper units, which are metric. So there we go. Now this cord here is sort of going to get in the way a bit. I'm just going to tuck that in there for now. We might need to do something better with that later. Well, there you go. There's the whole unit assembled now, and this is temporary. Remember, we're going to come back later in another video. I'm going to remake these white acrylic parts in aluminium. We'll get them anodized. We'll get it all set up again and make it look pretty. So thanks for watching this video. Oh, and just thought another upgrade I want to do on the Bridgeport is replace this plastic hand wheel. And I watched a video by Mr. Pete some time ago, and he was demonstrating a method for using a hand wheel like this as a pattern. And he poured a fair amount of scorn on Bridgeport for using such a cheap plastic hand wheel instead of something a bit more durable. And you can see with this one, it's cracked through in 2 places. That crack's gone right through to the back of the handle there. And although this part is made of steel, what I found originally was that the plastic part was spinning on this steel boss here, which made me think there was something wrong inside here. It turns out it was just that particular part. And and the other really frustrating thing is that this little steel knob here unscrews itself eventually, which is really bad. So I've got to do something better than that. So there you go, that's coming up, and as I say, thanks for watching. Check in later and we'll see some more upgrades for the Bridgeport. Okay, it's Prezzo signing out. See you on the next video. Mark, you've got to get more organised, mate.